Good afternoon, everyone, and welcome back to Tech Talk Tuesday here at Treadwell. Firstly, Happy New Year. This is our first session for 2026, so welcome aboard. Thank you for joining us. Uh, Appreciate your support. I hope you had a good break. Happy New Year, and so on. Now, today we are having a look around AS4586 anti-slip rating test. There's a few parts of the test. We're not going to obviously read the standard today or anything like that. We don't have time for that level of detail. We're going to discuss a couple of relevant parts of it around some testing and means of comparison between products, a bit of background or a bit of detail on how the tests are performed and why they're relevant, some of that sort of stuff. So before we go any further, though, a bit of a disclaimer. Firstly, obviously, we're not Standard Australia, so I can't tell you why or how or any of that sort of thing around what they meant when they wrote a standard. We can talk about our interpretation of it. And obviously, this is general advice we're discussing today. If you would like to have a project specific discussion, feel free to reach out to us. We'll have some contact details at the end, and we're happy to do that. But everything we discuss today is general in nature and not site specific advice or anything like that. So, without any further ado, um, AS4586, what is it? So, AS4586 is the AS NZS that sets out how pedestrians, so says new pedestrian surfaces are tested and classified for slip resistance. Now, there's four parts to the standard, and we're going to specifically talk about Appendix A and Appendix D today. There's also Appendix B and C, and we'll touch very briefly on them shortly, but the main detail, main discussion will be A and D today. So, why it matters, probably pretty straightforward, but obviously we want to specify on our project a classification that's relevant, um, and that ties into a little bit about some of the different test results we'll talk about shortly. Um, for example, there's no point specifying a test resistance for a dry floor when an area is always wet or it's going to have oil on it or something like that. So we're more interested in setting performance criteria that are actually relevant for the project at hand. And it's obviously good risk mitigation strategy to have the right product in the right application. And lastly, it means that we can compare different products, whether it be FRP, whether it be some other sort of flooring material, whatever it is, and ensure that we're using a product that's fit for purpose or going to perform how we actually want it to. So AS4586 Appendix A is a is the wet pendulum test. This can be done in situ, it can be done in the lab. As the name suggests, the surface is wet, and the pendulum with a specific shoe type or a specific foot shape type is used. That's dropped on the pendulum's laid to fall on the surface, very similar to a heel strike with your foot on the walking surface, and the level to which it uh, swings back or rises up after the impact is used to determine the slip resistance. Obviously, the lower it rises, the higher the slip resistance. So the P classification offers six classifications from 0 through to 5. I'm not going to read this table for you, but so at the bottom, P0 is very slow slip resistance, not suitable for wet pedestrian use. And then we go up to P5, which is very high slip resistance, suitable for high risk wet areas. So that's number one. And this is a wet pendulum test. This is suitable for wet areas, uh, ramps, walkways outside, those sort of things. Uh, Appendix Appendix B, as I mentioned earlier, is dry floors. So that would be inside buildings. You go to supermarkets, something like that, inside a building where it's dry. Wouldn't typically use FRP in those sort of situations, so we're not going to discuss that. And Appendix C is a wet barefoot classification, showers, bathroom floors, that sort of stuff. So once again, FRP is not generally used in those two situations, so we're not going to discuss those parts of the standard today. Now, just before we move on, then all our products here at Treadwell achieve a P5 rating um, to AS4586. It's important to note that a surface that achieves a P5 rating obviously has to be reasonably, shall I call it, aggressive. So something to think about, a nice smooth surface, might be aesthetically pleasing and so on, but it's not going to perform well in a slip test. The other thing is to think about is when you're comparing other materials. Some materials have a different classification as far as what results it will achieve in a slip test in one direction versus the other. So, for example, north-south versus east-west. Also important to consider that when you're doing a specification or you're evaluating products, to make sure that if you're going to use a product that's different in one direction to the other, you're using it such that the travel, the users of the structure, shall I call it, are going to walk on it in the direction that the slip resistance is most active or most effective. With FRP, these classifications apply in both directions. So, shall I call it north, south, or east, west? So there's no need to orient the product in a particular way from a slip resistance perspective. So you can walk, shall I say, north, south, or east, west, if you will, along a structure, and the slip resistance is going to be the same in both directions. So that's a P5 rating. Why would we specify that? Um, it's the highest classification you can have. So our suggestion is you'd specify P5 rating for boardwalks, jetties, external walkways, those sort of things, so that you can have confidence that the product is as least slippery, if that's a proper word. The anti-slip properties of the product used are as high as possible. Reduce liability, increase safety, ensuring that someone's as you ensure that the chance of someone injuring themselves is as low as possible from a slip and fall perspective. It's important to also note, and this is once again not something we'll discuss in detail today, but the National Construction Code gives some minimum performance requirements around testing to AS4586 different areas. So it's important that you consider those and use that to make an informed decision on what the most appropriate anti-slip criteria is for your project. But as I said, our general advice would be go as high as possible. You can't really have something that's too slip resistant, in my opinion. Much better off going to the top and knowing that the risk of someone slipping is as little as possible rather than doing something that's a bit lower and perhaps having some concerns. Next up, we're going to talk about the R rating. So this is to Appendix D of AS4586. This gives us the classifications from R9 through to R13. So Appendix A, we mentioned earlier, that's the wet pendulum test. This Appendix D is the oil incline test. So this testing includes oil applied to the surface and to the shoes that are used to do the test. So if you're in industrial areas, around machinery, ports, cranes, those sort of things where there's machinery, mine processing, water treatment, that sort of stuff, where we're going to see not just water on the surface, but a variety of different build-ups. This oil incline test, I would suggest, would be more relevant because it's not just a wet surface, it's a surface that's got oil on it as well, which is going to obviously be a more stringent, if you like, a test than just a wet surface. So we start at R9, which is low slip resistance, limited suitability in oil contaminated areas. The suggestion there is that a ramp from 6 to 10 degrees is going to be suitable with an R9 classification product. And we go through to R13, which is very high slip resistance, suitable for very high oil exposure, and a ramp of greater than 35 degrees, on a slope of greater than 35 degrees. Now, a couple of things to think about. Firstly is this test is done by a person in a harness walking along the surface that's got oil and so on it. And the classification is given at the point which that the person doing the test feels like they may be at risk of slipping. So that's where this number comes from, 35 degrees, and so on. And also something to think about, 35 degrees, if we supply a product that has an R13 classification, we can be confident that it's not slippery greater than 35 degrees of slope. However, there's other considerations around whether that's a suitable walkway. For example, AS 1657 has some requirements around sloped walkways and cleats and so on. This wouldn't exactly supersede that. And also, AS 1428 has gradients for ramps and so on. This wouldn't supersede that. So I just bring it up to make sure that we're not building a structure, or we're not specifying a product to a in a situation that's outside the scope or the intent of a standard. Um, Obviously, in some instances, like walkways alongside conveyors or those sort of things, it's not practical to have a walkway within a specific slope range because it's attached to the structure. It's not feasible to redesign the whole conveyor walkway, for example, to account for a particular slope. It may not work properly. So I just would just mention that to draw your attention to the fact that these gradient classifications, 6 to 10, 10 to 19, 19 to 27, 27 to 35, and it's greater than 35 degrees, are part of the testing regime, and you can be confident that something won't be slippery at that sort of gradient. But it's important to be aware that just because it's not slippery at that gradient doesn't mean it's not compliant. It doesn't mean that it is compliant, I should say. I'm not sure if that makes sense, but just want to bring it to everyone's attention. So R13 is what we achieved with our FRP product here. Once again, highest oil incline sleep resistance classification under AS NZS 4586. Once again, important to note or to use the right standard. We've talked about the P classification, that's Appendix A of AS 4586 previously, and the fact that may not always be appropriate. For example, inclined surfaces, oil contamination, these sort of things. And in fact, whilst it's a different test method, a product could do well in the Part A test and not do well in the oil incline test. So uh, it's important to specify a requirement that's relevant to the project at hand. I'm not sure if this makes sense. I should have added earlier, the Q&A window is open, so feel free to ask any questions as we go along. But we typically see this oil incline standard being referenced around ramps, obviously, but also areas where oil contamination, more industrial sites, mine processing, water treatment, those sort of industries where contamination on the surface other than just water, so there might be build-up of debris, oil, fluids, and so on. It's going to give us a more realistic indication of how that walkway material, the flooring material, is going to perform in that environment where there's things other than water on it. So we've talked about testing methods and the wet pendulum test, measuring slip resistance of wet pedestrian surfaces, which gives a value used to classify a P0 to P5. And we've talked about the oil incline test, which measures slip resistance of oil contaminated surfaces, gives us a classification of between R9 and R13. The variety of test results we got here, we're not going to read through the reports due to the matter of time, but something to think about. Happy to share them. We'd strongly encourage you to put something in a spec around what you require from a slip testing perspective for your project. And some of the tests can be done in situ, like the P5 or the pendulum test that can be done in situ. The testing apparatus is relatively portable. The oil incline test does need to be done in the lab. Larger samples required. The test apparatus is not exactly portable. Happy to have a discussion around different test methods. We've got a question that's come through, and I'll try and address it here. Is R13 used for specifying kitchen floors in architectural design? I'm not a specialist as far as shall I call them, residential domestic type buildings. So I couldn't comment on that. I would say that R13 is likely not the most appropriate standard. As we mentioned earlier, Appendix B is dry floors and Appendix C is wet barefoot. They may be more appropriate, especially Appendix C, but you'd need to speak to an access consultant, someone in that sort of area of expertise around something internally to a building. We haven't touched on those other appendices because our scope of work is generally external, and we feel that P5, the P rating or the R rating are the most appropriate um, classifications. That's the end of our discussion. Hope it was somewhat beneficial to you. So there's a lot of things outside the scope of today's discussion around where the most appropriate what the most appropriate classification would be for a particular project. But appreciate you joining us. If you'd like to have a project specific discussion at all, feel free to give us a call, 1800 246 800 for Australia, 0800 244 600 for New Zealand, or drop us an email, hello@treadwellgroup.com.au. Keep an eye out also in your inbox. We'll just send out a short survey after this. As always, your feedback is appreciated, good, bad, or ugly. If the session's worthwhile, good. If the session wasn't worthwhile, we'd really like to know that as well. And we'd like your feedback on other topics to cover. A lot of these topics come up. A lot of the topics we discussed today come up as part of client queries and client feedback. So your feedback's absolutely welcome. Don't hesitate to give some feedback around a session being not worthwhile or a waste of time or anything like that. That's definitely beneficial to us to get that feedback. So don't hesitate, don't hold back. If you'd like to give some, shall I call it, more negative feedback, that's absolutely valued and appreciated. And we'll see you again in a couple of weeks for another Tech Talk Tuesday. But welcome back to our sessions for the year. And thanks for joining. And we'll look forward to seeing you on the next session. Thank you.